Hello guys, this is Arvind here from Edureka and I welcome you all to this live session on DevOps Real Time Scenarios. So before we move any further, let us have a quick look at the agenda for today's session. First, we will talk about what exactly is DevOps and who is a DevOps engineer and why you should go for the DevOps certification course. Next, we will talk about the main topic of this session, that is the real-time scenarios, in which we will be covering the continuous integration scenarios, continuous delivery scenarios, DevOps data scenarios, and continuous testing scenarios. And at the end, we will have a look at the couple of case studies in which we will see how companies solve their problems by making use of DevOps practices. So this was the agenda, and I hope it is pretty simple to understand. And now, before we proceed further, I want you to subscribe to Edureka's YouTube channel and also hit the bell icon so that you never miss an update from Edureka. And also, if you're someone who's looking for a course in DevOps, then you can find the link for that course in the chat box. So before moving further, give me a quick confirmation whether you have understood the agenda and I'm clearly audible to you guys. So I can see a lot of positive response from the viewers. So now let us begin this session with our first topic, what is DevOps? First, we will talk about evolution of software development. DevOps evolved from existing software development strategies or methodologies over the years in response to the business needs. The slow and cumbersome waterfall model evolved into Agile, which saw development teams working on the software in short sprints lasting not more than 2 weeks. So having such a short release cycle helped the development team work on client feedback and incorporate it along with the bug fixes in the next release. While this Agile Scrum approach brought agility to the development, it was lost on operations which did not come up to speed with the Agile practices. Lack of collaboration between the developers and the operation engineers still slowed down the development process and releases. DevOps methodology was born out of this need for a better collaboration and faster delivery, and DevOps enables continuous software delivery with less problems to fix and faster resolution of problems. So now, since we have an idea about the background of DevOps, let us talk about the actual definition of DevOps. DevOps is a software development approach which involves continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring of the software throughout its development lifecycle. These activities are possible only in DevOps and not in Agile or Waterfall, and this is the reason why Facebook and other top companies have chosen DevOps as the way forward for their business goals. So DevOps is the preferred approach to develop high quality software in shorter development cycles, which results in greater customer satisfaction. So I hope you have got an idea about what exactly is DevOps. And now we will see who is a DevOps engineer. A DevOps engineer is somebody who understands the software development lifecycle and has the outright understanding of the various automation tools for developing digital pipelines or the CI/CD pipelines. DevOps engineer works with developers and the IT staff to oversee the code releases. They are either developers who get interested in the deployment and network operations or system administrators who have a passion for scripting and coding and move into the development side where they can improve the planning of the test and the deployment. So this gives you an idea about who exactly is a DevOps engineer. And guys, let me tell you that DevOps is a hot skill in the market right now. You will see a lot of job openings for the DevOps, and companies are ready to pay a good amount to the well qualified and deserving candidates. So as per Indeed.com, the average salary in US for a DevOps engineer is 121,000 US dollars per annum. So I guess that is not at all a bad amount. Now let us talk about the problems that are solved by DevOps. Here we will discuss like why an organization should adopt DevOps practices. So there are 4 points here that we are going to discuss. The first point is DevOps delivers value to customers. The greatest value realized through DevOps is that it allows IT organizations to focus on their core business activities. By removing constraints within the value stream and automating deployment pipelines, teams can focus on the activities that create customer value rather than just moving bits and bytes. These activities increase the sustainable competitive advantage of a company and create better business outcomes. So the second point here is reduced time cycle. Internally, DevOps is the only way to achieve agility to deliver secure code with insights. When you're delivering a new version, it can run side by side with the current version, and you can compare metrics to accomplish what you wanted to with the application and performance metrics. DevOps drives app development teams towards continuous improvement and faster release cycles. If everything is done well, this iterative process allows for more focus over time on the things that really matter. The third point here is the time to market. The most important problem being solved is the reduction of the complexity of the process, whether it is configuring a new cluster for existing applications or provisioning the environment for a new application. This contributes significantly to the business success by shortening the time to market, giving fast feedback on features, and making more responsive to the needs of the customer. And the final point here is the problem resolution. The greatest value of a successful DevOps implementation is the higher confidence in delivery, visibility, and traceability to what is going on, so that you can solve problems faster. From the dev team perspective, the biggest gain is a different kind of velocity, which is nothing but a reduced level of friction. When you have dev and the ops working together, there is a value in problem swarming, getting problems fixed faster and creating a level of bonding that results in better code and apps. The greatest value of DevOps is not wasting time. Aligning an organization's people and resources enables rapid deployments and updates, which allows the DevOps programs to fix problems before they become disasters. DevOps creates a culture of transparency that fosters focus and collaboration among the development, operations, and the security teams. I hope you are getting the reasons that why an organization should go for DevOps practices. So now we will come to the main topic of this session, that is the real-time scenarios. I would like to describe the format of the scenarios that we are going to discuss now. So scenarios are nothing but the real world challenges and how do you overcome those challenges, like the solutions to these challenges. So we are going to discuss the real-time scenarios for continuous integration, continuous testing, and continuous delivery. So let us start with continuous integration. So continuous integration is a widely praised idea. It has multiple benefits for the organization, such as improved productivity and lowered costs. There are a wide variety of CI/CD tools and services available for companies with all scale and budget. But applying continuous integration does not only mean to set up and run a CI tool or use a CI service. Even though many are convinced that CI could benefit their development team, there are companies who are failing to successfully adopt continuous integration practices due to organizational and cultural challenges. So now let us have a look at the challenges. So the first challenge here is individuals may see continuous integration counterproductive. So members of a development team have different roles, responsibilities, and priorities. Product managers' first priority might be launching new features. Project managers have to make sure that their team meets the deadline. And programmers might think stopping to fix a small bug every time will slow them down. They might feel keeping the build clean is an extra burden on them, and they won't be the beneficiary for their extra efforts. So this can potentially jeopardize the adaptation process. So what you can do in such a scenario? So first, you should make your whole team come on board before starting to adopt the continuous integration. Next, the CTOs, team leaders need to help employees to understand the costs and benefits of continuous integration. Next, you should highlight what and when will coders gain by dedicating themselves to a different working method that requires more openness and flexibility. The second challenge or the second scenario here is integrating CI into your existing development flow. So adopting CI inevitably comes with the need of changing some parts of your development workflow. Your developers might say that if it is not broke, let's not fix it. Mainly if your team has a big routine in executing their current workflow. Changing the workflow must be done with utter precaution. Otherwise, it could compromise the productivity of the development team and also the quality of the product. Without sufficient support from the leadership, the development team might be reluctant to undertake a task with such risks involved. So what you can do to overcome this challenge? So first, you should give enough time for your team to develop their new workflow and to select a flexible continuous integration solution that can support their new workflow. And second, you must ensure them that the company has their backing even if things might not go very smoothly at the beginning. The third scenario here is relapsing to the former testing habits. The direct effect of adopting continuous integration is that your team will test more often. More tests will need more test cases, and writing test cases can be time consuming. Developers often need to divide their time between fixing bugs and writing test cases. Temporarily, developers might be able to save time by manual testing, but it can hurt more in the long run. The more they procrastinate writing test cases, the more difficult it will be to catch up with the progress of the development. So in the worst case scenario, your team might end up going back to their older testing process. So what should be the way forward in such a scenario? So first, you should emphasize that writing test cases from early on could save a lot of time for your team and can ensure high test coverage of your product. And second, you must embed the idea in your company culture that test cases are as valuable assets as the code base itself. And the fourth scenario in continuous integration is that developers tending to ignore error messages. So it is a common problem when a bigger teams that work together, the amount of CI notifications become overwhelming and developers start ignoring and muting them. Therefore, they are also likely to miss the updates that are relevant to them. It can lead to a point where the coders develop a relative immunity to the broken builds and error messages. The longer they ignore the relevant notifications, the longer they develop without feedback into the wrong direction. This could potentially cause a huge rollbacks, wasting money, resources, and time. So in such a scenario, you should only send critical updates, and you should only send the notification to the developers who are in charge of fixing it and not to everyone. So it is a common practice to keep a team member on call for a day. On that day, he will be the only one in charge of reacting to CI notifications. Other team members don't have to worry about the notification. So these were the scenarios and their solutions related to continuous integration. So now let us talk about the scenarios related to continuous testing. So the first scenario here is getting requirements specifications right. So getting requirements right is nearly half of the battle won. If you have a very specific and accurate understanding of the requirements, you can design test plans better and cover the requirements well. Yet many teams spend a lot of time and effort in simply clarifying the requirements. This is a common pitfall, and to avoid this, teams can adopt a model-based testing and a behavior-driven development techniques to design test scenarios accurately and adequately. These practices will help address and resolve the gaps more quickly and enable them to generate more test cases automatically right from the early stages of a sprint. The second scenario here is the pipeline orchestration. The success of continuous testing and continuous delivery are tied to the pipeline orchestration. This means understanding how it works, why it works, how to analyze the results, and how and when to scale. Everything depends on the pipeline, and you need to integrate the pipeline with the automation suite. But the reasons teams fumble is that no single solution provides the complete tool chain required to build a CD pipeline. Teams have to typically search for the pieces of the puzzle that are right for them. There are no perfect tools, typically only best of breed tools that provide integrations with multiple other tools. And of course, an API that allows easy integrations with the more. In short, it is not possible to implement continuous testing without the speed and the reliability of a standardized and automated pipeline. The third scenario here is scaling up and managing the complexity. Another key challenge is that continuous testing becomes more complex as it moves towards the production environment. The tests grow both in number and complexity, with the maturing code and the environment becoming more complex. Tests must be updated every time different phases and automated scripts are updated. As a result, the overall time it takes to run the tests also increase towards the release. So what is the way forward in such a scenario? The answer lies in improving test orchestration that provides the right amount of test coverage in shorter sprint cycles and enables team to deliver confidently. Ideally, the entire process should be automated with continuous testing carried out at various stages using policy gates and manual intervention. This is done up until the code is pushed to the production. The next scenario here is creating feedback loops. Without frequent feedback loops at every stage of the development cycle, there can be no continuous testing. This is partly why continuous testing is difficult to implement. You don't just need automated tests, you need a visibility of the test results and the execution. Traditional feedback loops like the logging tools, code profilers, and performance monitoring tools are no longer effective. They don't work together and don't provide the depth of the insight required to fix issues. So real-time dashboards that generate reports automatically and actionable feedback across the entire software development lifecycle helps release software faster into the production with lesser defects. Real-time access to dashboards and access for all team members facilitates the continuous feedback mechanism. And the last scenario here is the lack of environments. Continuous testing means testing more frequently, and this requires hitting multiple environments more frequently. This presents a bottleneck if the said environments are not available when required. Some environments are available through APIs and others through various interfaces. These environments can be built using modern architecture, while others with monolithic legacy client server or the mainframe systems. But the question here is, how do you coordinate testing through all the various environment owners that may not always keep the environments up and running for you to test against? The only way forward here is virtualization. By virtualizing the environment, you can test the code without worrying about the areas that are not changing. Making the environments accessible and available on demand through the virtualization helps remove a significant bottleneck from your pipeline. So these were the scenarios related to continuous testing. Now let us talk about the scenarios related to continuous delivery. The first scenario here is deployments are taking too long. So distributed applications often require more than copying and pasting files to a server. The complexity increases when having a farm of servers. Uncertainty about what to deploy, where and how is a normal thing. Long waiting times to get our artifacts into the next environment of the root to live, delaying everything, testing, time to live, etc. So what does DevOps bring to the table here? Development and IT operations defining a deployment process in a blameless collaboration session, verifying what works and then taking it to the next level with automation to facilitate continuous delivery. This dramatically cuts the timing for the deployment, and it also paves the way for more frequent deployments. So the second scenario here is missing artifacts, scripts, and other dependencies. We frequently encounter failures recently after a new version of working piece of software is deployed, often caused by missing libraries or database scripts not being updated. This is again caused by a lack of clarity about which dependencies to deploy and their location. Again, fostering collaboration between the development and the operations can resolve these sorts of problems in the majority of the cases. When it comes to automation, dependencies can be defined, which helps a great deal in speeding up the deployments. Configuration management tools like Puppet or Chef contributes with an extra level of definition of dependencies. We can define not only dependencies within our application, but also at infrastructure and server configuration level. So let's say, for example, we can create a virtual machine for the test and install and configure Tomcat before our artifacts are published. So the next scenario here is the ineffective production monitoring. Sometimes monitoring tools are configured in a way that produce a lot of irrelevant data from production. However, other times they don't produce enough or nothing at all. There isn't any definition of what needs to be looked after and what are the metrics. So in such a scenario, what you can do is you can agree on what to monitor and which information to produce, and then put controls in place. Application performance management tools are a great help if your organization can afford it, like the App Dynamics, New Relic, and AWS X-Ray. So these were the scenarios related to continuous delivery. So now let us talk about the scenarios in DevOps data analysis. So DevOps is all about eliminating the risks associated with the new software development, and data analysis identifies those risks. To continuously measure and improve upon the DevOps process, analytics should span across the entire pipeline, providing invaluable insights to management at all stages of the software development lifecycle. From build and pipeline activities to continuous testing, analytics offers visibility into the roadblocks that hold the teams back from accelerating delivery and ensuring quality. Whether it is how much time builds are taking, where tests are getting stuck, or what percentage of the build is broken, DevOps pros rely on these qualified insights to influence and drive the software development lifecycle. So basically, now we will talk about the scenarios related to DevOps data. So the first scenario here is, say for example, you don't have enough time to analyze all the incoming data. So with all the data being generated at any given time, organizations need to accept that they can't analyze it all. There is simply not enough time in the day, and unfortunately, robots aren't quite sophisticated enough to do all of this for us. So for that reason, it is important to determine which data sets are most significant. In most of the cases, this is going to be very different for every organization. So before diving in, determine key business objectives and goals. So typically these goals revolve around the needs of the customer, primarily the most valuable features that are most important to the end users. So say for example, for a retailer, analyzing how traffic is interacting with the checkout page on the site and testing how it works in the back end is at the top of the list. So what are the solutions if you face such a scenario? So the first point here is you should make a chart. You should determine the impact outages will have on your business, asking questions such as, if X breaks, what effect will it have on the other features? And second point here is you should have a look at the historical data. Identify where issues have arisen in the past and continue to analyze the data from the tests and builds to ensure it doesn't happen again. Okay, so the next scenario here is silos, making it difficult to analyze and communicate about the data. Today, most of the organizations still operate with different teams and personas identifying their own goals and utilizing their own tools and technologies. Each team acts independently, disconnected from the pipeline, and meeting only with other teams during the integration phase. When it comes looking at the bigger picture and identifying what is and what isn't working, the organization struggles to come to one solution. This is mostly because everyone is failing to share the overall data, which makes the data analysis impossible. So to overcome this issue, you should overhaul the flow of the communication to ensure everyone is collaborating throughout the SDLC, that is the software development lifecycle, and not just during the integration process. So first, you need to make sure that there is strong synchronization on DevOps metrics from the word go. All the team's progress should be displayed in a single dashboard, utilizing the same key performance indicators or the KPIs to give management visibility into the entire process so that they can collect all the necessary data to analyze what went wrong and what succeeded. The second point here is beyond the initial metrics conversation, there should be a constant communication via the team meetings or the digital channels such as Slack. And the third scenario here is we're short of people and we don't have enough manpower to focus on analytics. So being short of people, we need smarter tools that utilize deep learning to slot in the data we are collecting and reach decisions quickly. After all, nobody has the time to look at every single test execution. The trick is to eliminate the noise and find the right things to focus on. So this is where artificial intelligence and machine learning can help. Many tools on the market today utilize AI and ML to do things such as develop scripts and tests to move and validate different pieces of data, report on quality based on previously learned behaviors, and work in response to the real-time changes. So while we are still on the cusp of AI innovation in the DevOps industry as a whole, there are strides being made to overhaul how we approach analytics through the pipeline. So these were the scenarios related to the DevOps data. And now we will have a look at a couple of case studies in which you will see how companies solved their problems by making use of DevOps practices. So there is this B2B marketing company which had the requirement to develop a marketing performance management solution that could provide a single platform to track their marketing activities and measure performance, deliver insights to the decision makers about the performance of the campaigns, and help them make better decisions. So this was the requirement of the company. So what was the solution to this requirement? So using DevOps, the marketing performance management solution was developed, and this ensured that the startup cost was kept to a minimum and the release cycles were as quick as possible, with these substantial features getting released frequently. A CI/CD pipeline was set up to enable continuous integration and deployment to test, develop, and stage production stack. The entire development workflow was automated by making use of Jenkins. So for those who don't know what Jenkins is a continuous integration and continuous delivery software, which is nothing but an orchestration system with hundreds of plugins to automate everything from building an application to testing it to the final deployment. So what was the result of this solution? So by making use of this solution, the company could cater to the growing demands of the customers while ensuring optimal resource utilization in addition to the accelerated time to market, shortest possible release cycles, and minimum downtime. So these were the benefits that the company achieved by making use of DevOps practices. So we will have a look at one more case study here. So there's this travel company called AMADEUS, which is one of the largest travel operators worldwide. Their systems interact with 90% of all the travel related transactions, serving more than 700 airline companies and around 600,000 hotels, processing more than 55,000 operations per second at peak loads, and the numbers are constantly improving. So guys, you can imagine here how big this company is. So this company too had a problem. So what was the problem? The company used a private cloud with virtual machines served by Vagrant and vSphere. However, the number of computing resources spent on maintaining the hypervisor layer of the infrastructure was too high, and the speed of processing was not optimal. While even several seconds of delay can result in huge losses for a travel operator. So what the company did to solve this problem? So the company chose Docker instead of Vagrant and decided to move to an on-premises cloud running OpenShift, Docker, and Kubernetes. By using a proprietary DevOps management system, they were able to efficiently utilize their whole IT infrastructure, taking the resources previously used by hypervisors. So this accounted for nearly 20% of their computing power. So this was the solution that was implemented by AMADEUS. And what was the result of this solution? The company got several million worth of computing resources by simply utilizing their IT infrastructure efficiently. In addition, Docker containers running in Kubernetes clusters allow processing the workloads in real time as there is no delay due to the absence of the hypervisor layer. So these were the case studies in which we saw how companies made use of DevOps practices and solved their real world problems. So guys, with this, we have come to the end of this session. If you have any queries, you can post them in the chat box and my team is ready here to help you out with anything. So I hope you have enjoyed this session. So that's all from me in this session. Thank you so much.